In this video, we're going to look at the second part of the fundamental theorem of calculus, and we're going to look at finding the average value of a function. So first of all, let's just look at the fundamental theorem of calculus again. Sorry, I lost the words for just a moment. So let's just say, for example, I would like you to integrate this generic integral. I'm going to call this f of x. It's a function of x because I don't have the specific values I'm going to put in there. So I'm just going to say we're going to integrate this from 0 to x. And let's use the function 3t squared plus 1 dt. And notice the t is just saying we've got some function in one variable, and then if we evaluate this function from 0 to x. So let's use the first fundamental theorem. F of x then is the process of finding this antiderivative. So if I find this antiderivative, that gives me t cubed plus t plus some constant. And I need to evaluate that from 0 to x. Okay, using the fundamental theorem of calculus, if I replace all of the t's with x, and then if I replace all of the t's with 0, and if I simplify this, I have a generic equation that will help me find the area under 3t squared plus 1 from 0 to any x value on the y, or along the x-axis. So this is a generic equation, kind of like when we were finding the slope equation before. You know, I said find the derivative of x squared. The slope equation is 2x, meaning we could find the slope at any point on the function. All we have to do is replace x with that value, whatever the x coordinate is. So now we've done the same thing. This is the area under 3t squared plus 1 from x equals 0 to any other x value. That's kind of cool. That's not the second part of the fundamental theorem of calculus. This next part is, but it's a good start anyway. So now I asked you to find f prime of x. So let's remember what f of x was. F of x was the antiderivative. It was this function, 3t squared plus 1 dt. So we found that function. Now what I'm asking you to do is find the derivative of that antiderivative. So that's what I'm asking now. Find the derivative of that antiderivative. Well, we did the work in the problem up above to find the antiderivative already. So now what I'm asking is for you to find the derivative of what we found from up above. X cubed plus x was the area under that function from 0 to x. So if we differentiate that, we end up with 3x squared plus 1. That kind of looks familiar. That really looks familiar. So I want to see if you notice anything here. Okay, I'm going to give you a moment there. Now let's look at another one and see if it was just in this situation that pattern came up. I'm not going to explain the pattern yet, just in case you don't see it. So this was the first one. Let's look at the second one now. What if we have a different function that is integrated from 3 to x? And I'm going to use a totally different function. I don't want to use 3t squared plus 1. Let's use the cosine of t dt. All right, let's use the first fundamental theorem of calculus. First fundamental theorem of calculus says find the antiderivative of cosine t. That's sine t plus some constant. and I'm going to evaluate that from 3 to x. So that means I'm going to replace t with x. I'm going to replace t with 3. And if I simplify now, I've got this function that is the sine of x minus the sine of 3. Oh, that's feeling different than the last one. That feels different. Now, what have I asked you to find f prime of x? So in other words, find the derivative of what you just did up above. Sorry, I want to be really formal and make sure this is all written out. All right, so let's do what we did. Let's say, all right, let's find the derivative of what we found from up above, which was the sine of x minus the sine of 3. And what we find then is that f prime of x, the derivative of sine x is cosine x. That part matches. And the derivative of sine 3, the sine of 3 is a constant, and the derivative of that constant is 0. I think it's time we might be able to generalize. I mean, having that 3 on the bottom didn't change anything because all that did was give us a constant here. So the derivative of the sine 3 is just 0. So it didn't matter what that bottom number was. So what if, I mean, sometimes we're not going to be able to find an antiderivative. So what if I said, find the derivative with respect to x from any constant, I'll call a, to x, of some function t. This is the fundamental theorem of calculus part 2. Oops, I put my x up a little too high. The Larson book calls this the second fundamental theorem of calculus. Most books call this the second part of the fundamental theorem of calculus. So based on what you saw up above, what would be the derivative of this antiderivative? I'll give you a moment. What we were seeing up above is that the derivative and the antiderivative will undo each other. In other words, if we find the antiderivative from some constant to x, the antiderivative is just going to undo all of that. This constant doesn't matter because the derivative of a constant is just 0. So what we find, the second part of the fundamental theorem of calculus says that this is just f of x. It's that original function that we started with, but instead of t, x is in its place. That's our shortcut. So if I said if f of x equals the antiderivative from 14 to x for the 3x e to the 4, oops, wrong variable, 3t e to the 4t squared minus 10 dt. Right now, you don't know how to find that antiderivative, but if I asked you then to find f prime of x, you wouldn't need to know what the antiderivative is, because we know that whatever the antiderivative was, if we then differentiate it, that'll get us right back to where we started again. So this would be 3x e to the 4x squared minus 10. Okay, that's interesting enough, but of course it's not going to stop there. That would be too easy. I think I'm going to stop this video and do the rest of it on the next video, because I want to do it in small chunks. So that's the second part of the fundamental theorem of calculus. We're going to expand on this in the next video.